So solving trigonometric equations. Suppose we have tangent of some angle theta is equal to the square root of 3. What is theta? Well, one way to solve this would just be to apply the arctangent. That would be the same as saying theta equals the arctan of the square root of 3. We can plug that into a calculator. Calculator is going to spit out a number. Let's check that out. Arctan of the square root of 3. And I get the number 1-ish. 1 what? What does that mean? Well, it's an angle. What kind of angle? Good question. Let's go back to the notes and see. So I'm getting that this is about 1-ish. Not exactly 1, a little bit more than that. What does that mean? Well, that's an angle. What kind of angle? Is that 1 degree? Is that 1 radian? Default behavior for these on most calculators ought to be radians. I was just using Desmos. Desmos does default to radians unless you change it. So that should be 1 radian. Let's look at the unit circle. Think about that. It's my best unit circle for the moment. Y-axis, x-axis, 1 radian. So that's the angle. Oh boy. And 1 radian, if you think back like to degrees, conversion to get rid of radians, we would divide by radians, multiply by degrees, 180 divided by pi, right? A straight line is 180 degrees, or pi radians. What is 180 over pi to get that in degrees? If you're not familiar with radians, I get about 57, almost 60 degrees. Okay. Let's see, here we go. So I have a radius. Let's say that radius would be about here-ish. And that's the angle theta that I'm looking for. And I know that angle theta is approximately 1 radian, which is approximately 57 degrees. Tangent is the square root of 3 there. What does that mean? Well, remember on the unit circle, tangent is y over x. So what point on the unit circle, y over x, gives the square root of 3? And you should recognize square root of 3 is one of the special values related to the special angles. That would be related to y equals square root of 3 over 2, x equals 1/2, which reduces down to the square root of 3. So that point up there ought to be square root of 3, oops, got that backwards, 1/2 for x, square root of 3 over 2 for y. Slope of that line is the tangent. It is the square root of 3, right? That's the slope of the line. Remember, tangent relates angles to slopes. What angle goes with that point? Well, the exact angle to go with that point right there is theta equals pi over 3. Let's test that out in our calculator. Let's get rid of the degrees, pi over 3. We could see that's that same number the arctangent said, right? Pi is about 3, right? So that's about 1. Now, if I think about, oops, wrong page, notebook. If I think about that slope here of square root of 3, that line actually keeps going in either direction, right? So I could extend that line this way. That line, right, that's still the same slope. So there's another angle that has that same slope. That would be this one over here. Okay, let's call that angle alpha. What is alpha here? Well, the arctangent did not give me this angle alpha. It definitely gave me this one up here, theta, in the first quadrant. Alpha here puts me in standard angle puts me in the third quadrant. Well, notice that there's a straight line running through here, and a straight line has an angle of 180 degrees, or pi. So to connect theta to alpha, I can just see here that, oh, they're pi apart. So my claim then is that alpha, that other angle, is equal to theta plus pi, because of the straight line that they're related through, the straight line passing through the origin there. Theta is pi over 3 in this case, plus pi I could view as 3 pi over 3, gives me an angle of 4 pi over 3. Seems reasonable. There's 1 pi over 3, 2 pi over 3, 3 pi over 3. Yeah, that would be 4 pi over 3. That makes sense. Let's check it out. Is that true? If I ask a calculator what is the tangent of 4 pi over 3, I should get the square root of 3 out of that. Double checking here, this point right here, the x value is -1/2. The y value is negative square root of 3 over 2. We know that from our symmetry of the circle and the values we memorized in the first quadrant. And so if I take that y over x of this point, that gives me negative square root of 3 over 2 divided by -1/2. Negative over negative is a positive. 1/2 divided by 1/2 is 1, leaving just the square root of 3 behind. So that checks out based on my knowledge of the unit circle. And my calculator will help me check that out further. Tangent of 4 pi over 3, oops, gives me 1.7-ish. And I should see that the square root of 3 is also that 1.7-ish. Same value. All right, are there any other angles that would solve this equation? So far we found 2 angles. The arctangent told us one of them. The arctangent told us that pi over 3 is one of those angles. We used this radius, making it into a diameter, and found another angle here. Now I could have, let's use a highlighter to clarify this a little bit. I could have measured in this direction as a negative angle. What angle would that be if I go in that negative direction? So heading that way. So this would be pi over 2. And if you think about symmetry here, I would go negative pi over 3 and another negative pi over 3. I claim that another answer would be 1, 2, negative 2 pi over 3. And I could keep doing this all day long, right? So let's go here to my unit circle again. And I know, because of my knowledge of the unit circle and special angles, that I have this angle right here, which is pi over 3. But I could get there in a lot of different ways. I could go around a complete revolution and then stop there. So another possible answer would be 2 pi plus pi over 3. I could also go around to get there in a negative direction. I could start here and wrap around in a negative direction. So that right there, that negative version would be, if you think about going around fully negative and then backing up pi over 3, that would be negative 2 pi plus pi over 3. So there, and I could do this all day long. There are infinitely many solutions to this equation. And so somehow we have to find a way to decide which ones we want. Let's back up a sec. Tangent of theta equals the square root of 3. Unit circle-wise, a slope of square root of 3 on the unit circle, right? That gives me that right there, which if I turn that into a diameter, within one revolution gives me 2 possible solutions. The first one here, I'm going to call that theta, and theta is going to be the arc tangent of the square root of 3. Now, why does the arctangent give that one and not one of the other ones? keep in mind that the arctangent has a specific range. And this is something we learned a couple sections ago. The range of the arctangent is negative pi over 2 to pi over 2. And that does not include the endpoints. So let's make that not a square bracket, but a parenthesis. On the unit circle, what do those angles look like? That would be on the right semicircle here. So this one happens to be in that first quadrant. To get another angle, in particular, I want that one right there, since they are basically a straight line segment about, the other within the first rotation, the other one is going to have to be pi plus whatever the arctangent tells us. And although the square root of 3 is special, it leads to the special angle pi over 3, it really doesn't matter what I was taking the arctangent of. So regardless of whether theta is one of those special angles or some other angle, this is always going to be true. Tangent is the slope on the unit circle, which is the y value over the x value of the point, always. So I'm always within 0 to 2 pi, right? One revolution on the unit circle. Sorry, my cat is trying to do trig with me. I'm always going to get those two solutions from the tangent on the unit circle. So right away, I can come up with those two. And again, arctangent gives me 1. Sometimes it's a special angle. In this case, it was pi over 3. And then the other one's always going to be pi plus the arctangent. And then based on those two, I can then add 2 pi over and over again and get other ones. So there are two solutions from 0 to 2 pi, that first revolution on the circle. And then otherwise, in general, I can take the first basic solution, which is the arctan of whatever value I have. In this case, it happened to be the square root of 3, but it could be anything. And if I just add 2 pi, I get another one. If I add another 2 pi, I get another one. If I add another 2 pi, I get another one. So in general, I could say we add 2 pi times n, where n is an integer. Now, integer, that could be positive or negative. So I could be subtracting 2 pi here. N could be 0, which means I get just that one. Now, that gives me versions of this up here in the first quadrant. That doesn't give me this other version down here. So otherwise, my other version was the arctan of square root of 3 plus pi, and then I add on multiples of 2 pi. And again, n is an integer. And because this one has an n and that one doesn't, this really doesn't clean up very well. And so those are the first two general solutions extended infinitely many times. And another way we could look at this is to check out a graph of the tan, thinking about y equals the tangent of x. So let's look at that to think about these numbers. Let's get rid of you, get rid of you, get rid of you, leave you. And then we're going to graph y equals the tangent and kind of explore what just happened there on the unit circle. So there's my graph of the tangent x, right? It just keeps repeating that pattern over and over and over again. Now, if I look back at my equation said the tangent of theta, here I'm using x, was the square root of 3. So if I also graph y equals the square root of 3, that's that horizontal line there, and I want to find all of those intersection points. The closest intersection here, that one right there is the value the arctangent gave me, the the square root of 3. 1.7 is restate that. The arctangent said if y was equal to the square root of 3, that's the 1.7, the angle should be pi over 3. The other angle I found within 0 to 2 pi is this one right here. That was the 4 pi over 3. So those two happen to be pi apart. So another way to talk about these solutions is I could keep adding versions of pi, but sometimes it's not that simple. So otherwise, let's turn that one off. This first solution and this solution over here, they are 2 pi apart, 1 revolution apart. And if I jump back here, this one compared to those two, they are also 2 pi apart in pairs. And those are the numbers I found. So we have a couple of options. We might be asked to look for an answer within a range of values. If we're not, then that means there's infinitely many solutions and we need to find a way to describe them. So let's just do some more examples like this.